Nestled in the heart of southwestern Ontario, Sarnia is home to some of Ontario's most stunning waterfront scenery. Spectacular sunsets, and above all, home to the Bluewater Bridge, towering over the St. Clair River like a steel sentinel to engineering achievement. The existing bridge was dedicated in 1938, and although strong for its age, has outgrown its ability to handle the heavy traffic volumes of the 21st century. In 1938, 1,000 vehicles crossed each day. But in 1997, 17 times the daily volume is realized. Projections reveal that by the year 2000, this number will increase to over 23,000 vehicles a day. It became apparent the bridge could not sustain such capacity, and a decision was made to twin the Bluewater Bridge, paving the way for a smooth transition into the next millennium. The new Bluewater Bridge was built to complement the existing structure, to be both an engineering feat as well as aesthetically pleasing. After many designs were proposed, it became clear that identical images would be confusing. So, the concept of the chosen Tide Arch Bridge was embraced as a model based on engineering of the 1920s. The new bridge measures 1,862 meters long, or 6,109 feet. The main span is 281 meters across the river, or 922 feet long, whilst the height deck towers 50 meters, or 155 feet above river's edge. The deck is 4 feet above the originals, to create a profile all its own. $10,066,000 kilograms, or 11,000 tons of structural steel, 23,400 cubic meters, or 31,300 cubic yards of concrete, 2.5 million kilograms, or 5,341,800 pounds of reinforcing steel, 50,300 meters, or 31 miles of foundation piling. Cost $80 million U.S., $100 million Canadian. On April 12, 1995, officials from both sides of the river held a groundbreaking ceremony commemorating the beginning of construction of the second Bluewater Bridge.
All the special guests, and ladies and gentlemen, thank you for demonstrating your interest in this project. We may have been one of the last international bridges to have been built across the Great Lakes, but we are the first to be twinned.
60 years ago, they decided to build this bridge, or 60-some years ago, and really things in this area weren't very good at that time. And we've had probably 50 or 57 years of real good times, and hopefully with the twinning of this bridge, that those times will come back again and that we'll have another 50 years of good times in this area.
This area represents a wonderful example of cooperation between two countries in a way that fosters the well-being, economic and social and personal, of both countries.
And as Mayor Kirkland's already pointed out, about 58 years ago, a group gathered close by here to start the construction of our present bridge.
And with the combination of the double stack tunnel and this bridge, which when completed will be the highest volume, the highest capacity crossing between the United States and Canada. 6 lanes versus only 4 for the Ambassador Bridge in Queenston-Lewiston. That sort of promise can be fulfilled and benefit the people of Ontario, the people of Michigan, the people of Canada, and the people of the United States.
We started in Canada back in June. They started driving pile, and it's been going fairly well. And we actually have 2 contracts going. We have the main span contract, and there's an approach contractor, Ellis Don, out of Toronto, and they've been going great guns. So they've got a little bit of a head start on us, but the contractor on this side, Walter Toby, and then the main span contractor, the joint venture of PCL and McCarthy, they're anxious to get going and catch up.
Reinforcing rods measuring 15 to 30 millimeters in diameter with epoxy coating to protect against corrosion were installed. The cages were tied together on the ground and lifted into place. They weighed as much as 25 tons. The main piers on either side of the river sit on 148 H-type piling, driven 105 feet into bedrock. The rebar for one main pier is 164 metric tons. The foundation lays 2.5 meters underground. "30 miles of steel piling was pounded into the bedrock, forming a solid foundation for 39 concrete columns supporting the 2 approaching spans to the main span. Precast concrete I-beams almost 6 feet tall were used on the U.S. side approach, while concrete tubs precast on the job site were used on the Canadian side. This lower arch extends eastward from the main pier to a temporary support tower. At 156 feet long, it weighed in at 80 tons. This Y-piece is 112 feet long and weighs 120 tons. It connects the main road bed with the bottom archway. One of the greatest aerial shows is about to get underway, with workers on both sides preparing to extend giant pieces of structural steel out over international waterways. This work is a spectacular part of the $100 million twinning project. This phase of construction is dramatic, but also the most dangerous phase. The 2 halves will meet in the middle, high above the St. Clair River. A 400-ton crane lifted the smaller 250-ton crane onto the bridge structure. As work progresses, the deck crane will be moved forward over the river. both sides of the bridge, a temporary tower is erected. It will anchor the bridge until both sides are linked. This pin is 6 feet long and 10.5 inches in diameter. This 1-ton device supports the temporary tower and allows movement of the mast for installation of cables. Cables will be connected from the top of the temporary tower to the 4 stay saddles at the front of the bridge. As the steel moves out farther over the river, more cables will be connected. These cables have been pre-measured and cut to ensure the weight is correctly supported and the geometry of the bridge is maintained. 16 3-inch diameter backstays, 8 on either side of the deck, are connected from the top of the tower to the enormous 1,000-ton capacity scissor jacks, 1 on each side of the bridge deck. These jacks are bolted onto the tie girder. The tension is transferred from the tie girder to the ground via a tie-down system. Engineering the project was sometimes reminiscent of being on a giant teeter-totter. By tightening the backstays and the tie-downs, it is possible to move the bridge up or down a few inches for alignment when required. The crane on the ground will lift a structural piece up to the roadbed of the bridge and place it onto a cart. An air tugger will draw this cart on a set of rails towards the front of the bridge. Then, the deck crane will lift it off the cart, swing it out over the water, and place it in its permanent position, where it will be bolted. More than 1/3 of a million bolts of various sizes and weight had to be selected, recorded, and included with each bridge piece when raised for installation. To get to work, the men had to climb steep, narrow, winding stairs 15 stories up, then strap on 30 to 40-pound tool belts. Wear a safety harness with 2 5-foot lanyards with shock absorbers, which must be tied off at all times in case of a fall. Debris nets are strung out over each half of the bridge, which are designed to catch loose bolts and debris, not humans. Ironworkers, carpenters, electricians, cement workers, and many more, perched 15 to 40 stories above the St. Clair River, have begun the hazardous task of spanning international borders. This was a minor injury, and we had others, but the Canadian ironworkers were proud that there were no lost time injuries. They spend their days hundreds of feet in the air, pounding pins, tightening bolts, and working with heavy equipment, sometimes with nothing more to stand on than a 12-inch beam. At dizzying heights, it's all part of the job, and they get used to it, they say. But remember, concentrate on your work, and don't look down. Ironworkers may be tied off with harnesses and lanyards, but their daring feats have fascinated more people than a high-wire circus act. People visited from all over the globe. The shores on both sides of the bridge looked more like a drive-in theater than a construction site. Erecting the mast was a huge challenge, but getting as high as you can get is the best part of the job. Towering 400 feet off the ground, the mast weighs 350 tons. With one panel alone measuring 50 feet and weighing 20 tons. Canadian workers installed the first girder to the center of the bridge Saturday, November 2nd, 1996. A linking ceremony was scheduled for Wednesday, November 6, 1996. The two final girders were to be installed simultaneously. Citing weather as a concern, the U.S. opted to go ahead with the linking on the 4th. During this installation, an American iron worker fell approximately 4 feet onto a platform, sustaining a stab wound just above the ribs from his own tools. He was taken to Mercy Hospital, where he had surgery and was released a few days later. These aerial shots were taped on November 5, 1996, the day before the Canadian tie-in. Sarnia Lambton is building an excellent bridge to the future, putting on a spectacular show of engineering achievement. Thousands flocked to watch the final piece of steel drop into place on the second Bluewater Bridge. This final piece weighed 38 tons and was 8 feet high and 4 feet wide. Around 10,000 spectators watched as the two huge subsections were joined at the center, 150 feet above the river.
Been there, done that. Move on.
Here we go then.
The project was the #1 tourist attraction in southwestern Ontario and will become an important link for the proposed superhighway between Mexico and Canada.
Stick my pencil in there, but probably wouldn't hold. Jeez. Make room.
I got to head in the car. Or we'll go there to take us some more of that.
Wave! Wave! Everybody wave!
Whose broad stripes and bright stars through the perilous fight. All the ramparts we watched were so gallantly streaming, and the rockets red flared the whole Canada, our home and native land. True patriot love in all thy sons command, with glowing hearts
in a dual capacity today as a host from the warden for the county of Lambton and also the mayor of Point Edward, Richard Kirkland, and our member of parliament, Mr. Roger Gallery.
I had the opportunity to walk the first bridge that was built. My mother and dad, they opened it up, and I would hope, Lou, that that's in the plans for July the 12th, so that all the people that are here today have the opportunity to walk over that bridge.
This is an important, it's an exciting, and it's certainly a historic day. From each level of government are here today to participate in this ceremony. Symbolic acts have meanings in different ways and on different levels for each of us. And for the students that are here, I know somewhere from Bridgeview School and from King George VI School, your memories and impressions of this morning are going to be the first-hand historical accounts in the latter half of the year's 2000s.
At this point, the two gentlemen that I want to pass out these inaugural commemorative bolts to are not here. They're still doing their job. They're up on the bridge. And one of the gentlemen's name is Don Cran. And this is Don's last bridge. He's going to retire after this bridge. And he works for Midwest Erectors. And the other gentleman that I'm waiting for is a gentleman by the name of Steve Poisson. He's from the local 700 Ironworkers Hall here in Sarnia. And we found it fitting to give them the second and third commemorative bolts. The first bolt went to CHOK and the media, representing the media and the amount of coverage that they've given us on this event and also prior to this event. It's just been outstanding and we thank them greatly.
This group picture includes Canadian and U.S. ironworkers and was taken 2 days after the linking of the bridge. The last piece linking the U.S. and Canadian archway was only out by 3/8 of an inch. This group picture on the crane was taped after the connection of the archway. Aluma beams were installed between the road stringers 6 inches from the top of the stringers and supported by Williams rods. 20-foot Aluma joists on 12-inch centers were laid on top. Three-quarter-inch plywood was nailed on 2x2 nailing strips and bedded into the Aluma joists to support the concrete base of the roadway. After the concrete was poured, the Aluma stringer and plywood were removed. Nelson, or shear studs, anchor the concrete deck to the support steel, creating a composite deck. This fence was erected in the middle of the bridge at the border as a reminder that this is, after all, an international crossing. The reinforcing bar varies in size from 1/2 to 3/4 of an inch. Double layers going in different directions and epoxy coated for corrosion protection. Concrete was poured in summer and winter. It was both pumped and hauled by crane to the deck. The slab varied between 8 and 12 inches in thickness. During winter, the concrete was covered under thermal blankets and hot air was forced in. Generated hot air was blown by electric fans into the blankets, keeping the slabs warm, allowing the concrete to cure properly. A slump test ensured all concrete met the high specifications for the job. This test allowed for a 3-inch slump. Heat and cold will cause steel to expand and contract. Expansion joints were placed along the bridge length, with special joints placed at the beginning of the main span on both sides of the bridge. The bridge sits on sliding bearings, allowing it to move as it expands and contracts. Once the steel erection was completed, the iron workers moved out and the painters moved in. These aerial shots are compliments of the painters. The electricians were busy with the installation of transformers and the lighting of the bridge. The guard railing was installed for the protection of pedestrians. The concrete is sprayed with tar primer sealer. Then a coating of rubberized tar is applied. Next comes a layer of reinforcing remay membrane. Another coat of rubberized tar. A layer of tar paper. "20 millimeters of flexible asphalt. And 30 millimeters of durable asphalt.
With a percent compaction.
What percentage?
We're looking for 93.
93%
on the base coat.
compaction.
As the work on Bluewater Bridge number 2 winds down, Sarnia, Point Edward, and Port Huron can be proud of such an engineering feat, cementing the friendship between our two countries. Opening up a gateway of opportunity, the new bridge mirrors our extensive trade, which is expected to blossom to $450 billion in the year 2015, nearly double today's $270 billion. With a call for open borders, a coalition believes our borders should be opened up completely by the year 2012, removing the burdens of inspection which slows traffic, tourism, and trade.
Good, Lou.
So how does it feel to work on a project like this?
Feels great. A magnificent project like this, it's a badge of honor for all the iron workers that have worked on it. Me personally, it's been an honor and a privilege to be part of this project, to work with all the
Well, the good men that have all put their efforts into making such a great project. Thank you.
So sums it up Tim Gorsman, Union Steward for Iron Workers Local 700. The new Bluewater Bridge, a link to the future.